All right, let's talk a little bit about roots of negative numbers. Probably it's been a while since some of you have seen negative radicands, so let's talk about how we're going to go about simplifying them. All right, I hope you're all following along with me here when I read this part. The first key to simplifying negative radicands is to quote-unquote pull out an I. All right, now keep in mind our definition of complex numbers is I equals the square root of negative 1. So given the square root of negative a, I can actually kind of pull out an I because the I represents the square root of the negative 1. Okay, so let's actually do this with a few examples because you guys like totally hate when I talk about A's and X's and Y's and Z's. All right, so for example, square root of negative 16. First thing I want to do is pull out an I and write it as I the square root of plain old normal 16. Okay, so then I can say, okay, well, do I know what the square root of 16 is? Absolutely, it's 4I. All right, so again, let me step through this one more time for you guys. You can see how, given the square root of negative 16, my first step was to rewrite it as I the square root of 16. And then I concerned myself with simplifying the square root of 16. All right, let's do another one. Square root of negative 48. All right, again, what's my first step going to be and what is my first step always going to be? To rewrite this as I the square root of 48. All right, here's where it gets a little bit hairy. How are we going to simplify the square root of 48? Again, some of you haven't seen this in a while. All right, so let's think of doing a factor tree. All right, all of you guys did that in K through 12. So if I think of factors of 48, I'm looking for things where I know what the square root would be. So as I'm thinking about 48, I know that it is 16 times 3. All right, why in the world would I want to think of that as 16 times 3 and not just say 4 times 12? Well, I know that 3 is a prime number. I can't do the square root of 3. That doesn't make any sense to me without my calculator, but I do know the square root of 16. The square root of 16 is in fact 4. All right, and so notice here that where I start with I, the square root of 48, I can actually evaluate the square root of 16 that's in there as 4, and that leaves me with just the square root of 3. Now, I'm not expecting all of you to jump up and down and say, woohoo, I got this. This makes total perfect sense. It's really going to take some practice in the homework till you guys get this stuff down. All right, the second key to simplifying negative radicands, all right, is given a, like, say, bi squared, where bi is in parentheses, we know we can distribute that square as b squared I squared, all right? Well, I'm saying this results in negative b squared. Is that obvious to you? Well, it may be if you think back to the introduction where I talked about I squared being negative 1. Please keep in mind every time you see I squared, you have got to convince your brain to fire, hey, that's not really I squared, that's just negative 1. Okay? So again, let's run through a couple examples here. If I have 4I all squared, well, I know that that is 4 squared I squared. All right? What is 4 squared? What is I squared? Keep in mind there, 4 squared, yes, it's 16, and I squared is the negative 1, so I get the negative 16. All right, let's do another one. Negative 3I all squared. All right, well, again, I kind of distribute my square, so I have negative 3 squared and I squared. That's going to give me 9, because negative 3 times negative 3 is positive 9. My I squared is negative 1, and I end up with negative 9. Okay? All right, oh, I just love how I've left bits and pieces of animation floating around the screen. Well, at least you know that these lectures will keep you somewhat entertained. All right, addition of negative radicands. All right, so how can I add these two things? Because right now it looks like I can't, because they're not like terms. I see a square root of negative 27, I see a square root of negative 48. I can't just add these together, guys, and end up with like negative 75 under there. Okay, so the first thing I have to do is what I'm always going to do, which is pull out an I. All right, so you see how I've pulled out an I, and now I want to try to simplify the square root of 27 and the square root of 48. All right, again, I'm thinking of factors. I'm going through my factor trees, and I know that the square root of 27 is 9. Well, I know that 27 is 9 times 3. And I know that 48, as we saw from the previous slide, is 16 times 3. And I can plug square root of 9 in my calculator and get a nice number like 3. And I can plug square root of 16 in my calculator and get 4. All right, so then I can rewrite these as 3i the square root of 3 and plus 4i the square root of 3. Okay, so again, the square root of 16 becomes 4, and the square root of 9 becomes 3. Okay, so can we add these two terms? The answer here is yes, we can, because both of them have an I and they have a square root of 3. Let's say one had been square root of 3 and the other one had been square root of 2. Then the answer would have been no. All right, what if one had had an I, but the other one had not had an I? Then again, the answer would have been no. We can only add these together because they both have an I and they both have a square root of 3. All right, and so given 3i the square root of 3 plus 4 more i's the square root of 3, what do we end up with? We end up with 7i the square root of 3. All right, subtraction of negative radicands is performed the exact same way, and in the video examples, I do subtraction for you guys. All right, again, don't you love it how I just leave bits and pieces of animation out? All right, multiplication of negative radicands. All right, can I just multiply these things together, get the square root of negative 7 squared, which would be 49, and end up with a 7? All right, anybody here think the answer is going to be 7? All right, let's see. First step, just like always, is to pull out that I. Okay, so I have I the square root of 7 times I the square root of 7. All right, what do I do now? Well, I'm just going to multiply these terms together. Since I'm multiplying two i's, I get I squared, and since I'm multiplying two square roots of 7, I get the square root of 7 squared. All right, what happens? All right, well, I squared, remember, is negative 1, and the square root of 7 squared is simply 7. Okay, and so I end up ultimately with negative 1 times 7, which is just negative 7. And so you can see the answer is not positive 7, it's actually negative 7 because we have to pull out the two i's, which give us an I squared. All right, division of negative radicands. All right, what do you think we're going to do first? All right, your life's on repeat. This is Groundhog Day or 51st dates. We're going to pull out an I. All right, and so you can see from the first to the second fraction, all I did was write what's in the radical as positive and pull out an I. What do you think happens with these i's? Yep, they do cancel. All right, we can cancel those i's because we're dividing one on top of the other in the same way we would x's or some matching number like 2. All right, and so I've canceled my i's, and here I have the square root of 20 over the square root of 2. All right, one of the tricks I will work with you guys on in the lab is instead of writing this as a radical divided by a radical, let's write it as one fraction inside one radicand. All right, so you notice how I've just written it a little bit differently, and I can do this. This is allowed. All right, and so now instead of my eyes looking at trying to divide two radicals, my eyes ultimately see 20 divided by 2. Well, can I divide 2 into 20? Absolutely. It's just 10. And so my final answer is the square root of 10. All right, let's try writing in standard form. All right, keep in mind standard form is a real part plus an imaginary part. And as you can see here, I've got a whole lot of stuff going on. All right, but just as it's always been, my first step is going to be to pull the I out of a negative radicand. All right, and so I have my I now on the numerator, and I ask myself, hey, can I simplify the square root of 128? And the answer is yes. 128 is simply 64 times 2. Do we know what the square root of 64 is? Hopefully you're all nodding your head, smiling, or rolling your eyes and going, of course, it's just 8. All right, and so you can see how I've pulled out an I and I've simplified the square root of 128. All right, so right now in my numerator I have negative 8 plus 8i, square root of 2, all divided by 4. The next key step here is to write that one fraction as two fractions, where they both have the 4 under them. Now, why in the world would I want to do this? The reason is, when you guys see it written this way, it becomes a whole lot easier to simplify, because we do better with dealing with pieces than the whole. So, the first thing I read to myself is negative 8 divided by 4. Well, what's that going to be? That's going to be negative 2. All right, and similarly, I can divide the 4 into the 8 and get 2 again. So my final answer is negative 2 plus 2i the square root of 2. All right, now keep in mind the 4 only divides into the 8. It does not divide into the radical. All right, so you guys hear me. I'm going to say it one more time. The 4 only divides into the 8. It does not and never will divide into the radical.